Hi, and welcome to another physics class. In today's lesson, we're going to talk about how to solve parallel circuits the easy way. Now, in my previous video, I talked about why I write parallel the way I do. And it's because when you calculate total resistance, you have to remember to take the inverse of the answer that you get. So to me, this is an easy reminder for me to do. Now, the equations, sometimes you may see that they ask you to go 1 over RT, 1 over R1, plus 1 over R2, and so on, and eventually take the inverse of that. Personally, I find using the resistor value with a -1 at the end of it to be much easier. We're going to see an example of both on the other side, but they mean the same exact thing. So, for example, in this problem, it says find the total resistance, or the RT, sometimes referred to as the R equivalent, of the following resistors connected in parallel circuit. So now we've got three resistors, R1 with 200 ohms, R2 with 470 ohms, and R2 with 220 ohms. And the two methods that you see work the same exact way, or get you the same exact answer. It just depends on which one you want to do. Notice that on the left, you eventually get 0.0117, and you do have to put a 1 over that value to get your answer of 85.67 ohms. Or the method that I personally like to use is simply just do the inverses as I'm writing it down. To me, that's easier because it's less buttons in the calculator, and there's no need to be using parentheses or anything like that. At the end, you still have to put the final inverse on that 0.0117, regardless, in order to get your answer as 85.67 ohms. So now I hope you understand why I write parallel circuits the way that I do. Now, there is a little trick for doing total resistance, and this will help you out if you ever have multiple choice questions, which in this case you will. But here's a trick to it. It's that the total resistance is always less than the value of the smallest resistor branch. So let's say you have three resistors, and the values are 6, 9, and 18. Well, 6 is the smallest one. So you should automatically know that the total resistance has definitely got to be less than 6. Now, if you want to go a little bit further, you can figure out between what numbers there will be in. And that is by taking the total resistance will always be between the smallest resistance value divided by the number of resistors that you have and the value of the smallest resistance. And it's a little confusing, so let's look at this example. We've got three resistors in parallel with values of 6 ohms, 9 ohms, and 18 ohms. Right off the bat, if you're looking at a multiple choice answer, if there's a value of 6 or anything greater than 6, they should all be canceled out. Because we know that automatically total resistance should be less than 6 ohms. Now, if we want to figure out between what numbers they are, the smallest resistance is going to be 6, and there are three resistors. So 6 divided by 3 is equal to 2. So now we know that our total resistance can be anywhere between 2 and up to 6. So when we do our calculation for this problem using our equation, and we do the inverses of each resistor and finally do the inverse of the final answer, we get our total resistance as 3 ohms, and 3 is definitely between 2 and 6. So it checks out. Again, this is just a little trick to save time, easy way to knock out answer choices in a multiple choice question. So, but we're going to go ahead and solve these problems, and I'll show you different methods. All right, so solving parallel circuit problems. Now, the thing with parallel circuit problems is they could be drawn in any kind of way. It's not parallel because of their geometry. It's not about their shapes, but it's because each branch has its own direct power line. And you could have any of these four depicting the same exact thing. How we refer to them as R1, R2, and R3 depends on where they are from the power source. So these arrows help you understand which way the flow is, which one would be considered the first resistor or the first branch, and so on. So we got three resistances, a 20 ohm, 30 ohm, and a 60 ohm, and they're connected in parallel to a 90 volt battery. So there's some questions in there for you to do. And just like our series one, we're going to do our chart, except this chart's going to be a little different one. So in series, we called it the virus chart because it was VIR. And in this one, we're going to call it the RVIP chart. Now, I know it's a stretch for most of you guys, but RVI is actually the 3 letters in my name. So it was easy for me to remember. You could think of it as a red viper, or you could think of it as, VIP people, reserve. So it's RVIP. It's however you want to remember it, but for me, it was always easy to remember. Now, the reason I'm doing this is because I promise you that there's going to be patterns, and the same patterns will follow from the previous chart. All we're doing here is changing our letters or the way the columns will look. So when we take RVI, R would be considered the first column, V would be considered the second column, and I would be considered the third column. And the same pattern from the previous chart still holds true, meaning that the second column remains the same all the way down. That's the voltage. The third columns will add up together to get you the total value in the third column. That's your current or your I. And there's really no pattern for the first column, just like the previous one. But there's a little way to check, if your total resistance is true, and that's to remember the trick from what I showed you earlier. All right, so let's go ahead and get to it. We had our problem, and we're going to fill out what we can. So we had 3 resistors. We put those down. And remember, you cannot pick and choose. You have to put it in the order that they are from the power source. And the voltage was 90. So you can play tic-tac-toe again. Now, this purely depends on which route you want to take. Not every problem is going to follow the same exact steps. And however, if you play the tic-tac-toe game on this chart, then you're always guaranteed to be able to solve any problem. So we can tackle this a couple of different ways. First one being that we can go ahead and solve for the total resistance. And you can do the equation 1 over RT, take the inverses of each one, and you're going to get 0.01. Remember that you got to take that final inverse of that as well too. So the total resistance comes out to 10. And if we do a quick check, the smallest resistance value was a 20. So we know it's definitely got to be less than 20. And that is true. It's 10. And if you really want to get there, you had 20 divided by 3, which is a little over 6.5, 6.6. So our total resistance should be between 6.6 and 20. So that checks out for us. Now the voltage, remember this pattern holds true. Everything in the second column is going to remain the same. The voltage drop for parallel circuits is always the same at each branch. So now those are 90. And now we can go ahead and solve for the current, using Ohm's law. You can pick whatever you want to do. Really doesn't matter. I did the first 3 resistors. So 90 divided by 20 gives us 4.5, then 3, and then finally 1.5. And the reason I left that last one blank, didn't show any work for it, is because there's 2 ways you can get that answer. You can get that answer by simply adding up the 4.5 plus 3 plus 1.5. Remember, that's the pattern that we talked about, and that will add up to 9. Or if you already have the total resistance and the total voltage, you can do that and solve for that. So, you can take 90 divided by 10, and it'll still give you 9. So this is the advantage of a little tic-tac-toe. You can pick what you want to do, and ultimately there's easier ways to solve it. Speaking of easier ways to solve it, there's another way to do this. So let's say that we take the same exact problem, 20, 30, 60 resistors. They gave us the voltage was 90. And so, we don't want to go and do the total resistance first. And that's perfectly fine if you don't want to do that, because you can always go back and put the values for the voltage, and those are all going to be 90s. And now we can solve for the individual branches first. We showed the work in the previous one. So you could take your 90 divided by 20, 90 divided by 30, and so on, and get your individual branch values for your currents. You add those 3 up, and you get the value of 9 for the total current. So now, as you can see, the only thing that's remaining is our total resistance. So now we can go ahead and use Ohm's law again and take voltage divided by the current, 90 divided by 9, and that'll give us our total resistance in this one. So if you find this method easier and the problem allows you to do it, by all means do so. You're not limited to using that equation, but it just purely depends on if you have enough information or not. All right, so solving parallel circuit problems. Here's another example. This one, they gave us the circuit. Now, the R1 is going to be considered 12, R2 is going to be considered 24, and R3 is going to be considered 20. Again, remember I said it's not because of their geometry that they're considered parallel. It's because each branch or each resistor has its own direct supply, power supply wire, and so on. So at R1, we see that in that branch, there's an open switch. So technically that one is not working there. The other two would be considered to be working, but we're going to go ahead and solve for the values for each single resistor. So we're going to go fill out everything that we can. Again, we had our 12, 24, and 20, and our voltage was 120. So I'm going to play tic-tac-toe again, except I went a little bit different route, the second route that I showed you, and that was that I wrote my voltages down first. Then I solved for each individual branch of the current. So now that I have 120 divided by 12 and so on, I found those. And then I found my total current by adding those, the 10, the 5, and the 6. So now I have 21 for total current and 120 for total voltage. And now I can easily go and solve for the total resistance. And that's by using Ohm's law equation. So in this scenario, I did not use the equation 39, which was the inverses for finding resistance, and it still led me to the same answer. So you can pick and choose what you like, but again, these charts will help you out tremendously. Okay, so here's your turn. This is considered a parallel circuit. So we have everything labeled. Make your chart, pause this video, solve it, and you'll see my answers in a few seconds. All right, so hopefully you got the same answers, with the total current being 13.98 and the total resistance being 4.29. Hopefully this video has been helpful. Thank you and have a great day.